This is Cambridge International Mathematics, Paper 2 Extended, 607/22, October-November 2018. This is the formula list. Question 1. Write 49,059,300, correct the three significant figures. So three significant figures, we check the fourth one. It's 5 or above, so the third one would increase by 1. So this would be 49,100,000. Write your answer to part A in standard form. So standard form, we'll have to move the decimal point 1, 2, 3, 4, 5, 6, 7. So the answer will be 4.9 times 10 to the power of 7. Question 2. Find the cube root of 3 and 3 over 8. So the cube root of 3 and 3 over 8, the 3 would be equivalent to 24 over 8. And there we have also 3 over 8. So this would be equivalent to cube root 27 over 8. So you can take the cube root of each part, cube root 27 over cube root 8. This is equal to 3 over 2. So the answer is 3 over 2. Question 3. Shade two small squares so that the shape has exactly one line of symmetry. So here we can look at the shape. We can see that to have a line of symmetry, only one line of symmetry, and we only have to shade two small squares. So if we shade this square here and this one, then we will have, and this would be our line of symmetry. This would be correct. Question 4. The vector p is equal to minus 3, 5. Find the column vector 3p. So it's just 3 times minus 3, 5 is equal to minus 9, 15. So the answer is minus 9, 15. Part B, find the magnitude of the modulus of P, giving your answer in third form. So this magnitude of is equal to the square root of both the terms of P squared. So minus 3 squared plus 5 squared is equal to the square root of 9 plus 25 equal to the square root of 34. Third form means that there has to be a root. So it's a square root or a cube root, just we have a root. This is called third form. So the answer here is just square root 34. Question 5. F of x is equal to modulus of 2x minus 7 for all real x. Find f of 2. So we just replace 2 in the formula. So this would be 2 times 2 minus 7. So just 4 minus 7, which is modulus of minus 3. This is 3. Because all the modulus or the magnitude of a negative number is the positive of it. So the answer would be 3. Write down the range of f of x. You can see that f of x here can never be negative, as it's the modulus or the magnitude of have a modulus here, those two signs. So it will always be positive. So the range of f of x is always going to be greater than or equal to 0. Question 6. The line with the equation 2x plus 3y is equal to 6 is drawn on the grid. On the grid, show clearly the single region defined by these three inequalities. 2x plus 3y is less than or equal to 6, x is greater than or equal to minus 3, and y is less than or equal to minus 1. So we already have 2x plus 3y is equal to 6. We want the region below it. So we want the numbers below this line. We also draw x is equal to minus 3. So x is equal to minus 3 is going to be this line. And y is less than or equal minus 1. So we draw y is equal to minus 1. We're going to be this line. So you want the region that is below 2x plus 3y is less than or equal to 6, and x is greater than or equal to minus 3, and y is less than or equal minus 1. So this is our region here. Okay. This is our region. Question 7. Factorize 64x squared minus 1. So here we don't have any x terms, so the two terms in the brackets would be the same, but one would be have a positive sign and one will be have a negative sign. So 64x squared, this would be 8x, and 8x. This term is minus 1, so question 7, factorize 64x squared minus 1. So we see that we don't have any x terms, x to the power of 1, so the brackets would both be the same. The brackets would both be the same, but one would have a positive sign and one would have a negative sign. So 64, we can have here 8x and 8x. This term is minus 1, so we'll have minus 1 and plus 1, as they, when they're multiplied by each other, would give us minus 1. So this is our final answer, 8x minus 1 times 8x plus 1. Part B, 2y squared minus y minus 6. So we'll have one bracket will have 2y, the other will have y. Here we have a minus 6, so we'll either have 2 and a 3 or a 6 and a 1. So the 6 and a 1 will not work. This term will be have to have minus y, so we can have this term will have 2y, so this would be minus 2, as minus 2 times 2y would give us minus 4y, and then this is plus 3, as then minus 4y plus the 3y from this term would give us the minus y. So this is our answer, 2y plus 3 times y minus 2. Question 8. 2 cubed divided by 2 to the power of 7 is equal to 2 to the power of p. Find the value of p. So this term, 2 cubed divided by 2 to the power of 7 is equal to 2. We have the same base, which is 2. So this will mean 2 to the power of 3 minus 7. This will be equal to 2 to the minus 4. So here p is equal to minus 4. The value of p is minus 4. Part B, the square root of 2 to the power of 5 is equal to 2 to the power of q. Find the value of q. So the square root of 2 to the power of 5 is equivalent to 2 to the power of 5 all to the power of a half. And the square root is like similar to the power of a half. So 2 to the power of 5 to all to the power of a half. So we multiply the 5 by the half. It's equal to 2 and 5 over 2. So the q is equal to 5 over 2. Question 9. An archer shoots 150 arrows at a target with sections colored gold, red, blue, black, and white. The table shows her results. Complete the compound bar chart to show these results as percentages. Here for the compound bar chart, the area, so the area of the gold here, is equivalent to the frequency, which is 30. So this is 20, from 0 to 20. This is the width, and multiplied by its length here would give us the 30. So this is 20 times this has to be 1.5 to give us the frequency, which is 30. The same, the red, this is from 20 to 60, so it's 40 times the 1.5, this give us 60. For blue we want 36, So to get 36, to find the width is 36 over 1.5. This is 24. So it's from 82 to 84. We'll have to have also the same width. To 84. This is blue. Don't forget to mark it blue. The black frequency is 15, so 15 over 1.5 is 10. So this would be from 84 here till 94. This is black, BL. And then the white is 9. 9 over 1.5 is 6, so this is the remaining 6. This is white. Question 10. Solve 4x plus 9 is less than or equal 3 times 2x minus 1. So this is like 4x plus 9. We open the bracket. It's going to be 6x minus 3. Then we move all the terms 4x plus 9, we move it to the other sides. So it will be 0. It's less than or equal 6x minus 4x minus 3 minus 9. So this is equivalent to 2x minus 12 is greater than or equal to 0. So this means that we can divide by 2. 0 is less than or equal x minus 6. So here x is greater than or equal to 6. So this is our answer. Question 11. The diagram shows 9 sketch graphs. Write the letter of the graph which shows each of these functions. The first one is 2x minus 3. We know that this is a linear one, so it's either a or h. We can substitute when x is 0. Here when x is 0, we'll get that fx would be equal to 3 minus 3. So this is our y-intercept. So it's minus 3, so this is the right answer. H would be the right answer. It's a linear intercept minus 3, so here our answer is H. The second one is x squared minus 3. So we know the curve that of x squared looks like either B or G. So here if we substitute x is 0 to know the y-intercept, we get also that the y-intercept is minus 3. So it will be B, as here the y-intercept is minus 3. So the answer is B. The third one, f of x 3 minus x cubed. So we can see that x cubed is either E or C. But this is minus x cubed. So minus x cubed looks C because E is the curve of x cubed. But C, it has an opposite graph, so it's the one that we want. This is C. Then the third one is x minus 3 all squared. So this is also an x squared curve. So it's either B or G. We also can substitute here. If we substitute here with 0, then the y-intercept would be 9. So here we see that the y-intercept is B minus 3, and here the y-intercept is in the positive. This would be 9. So the answer would be G. Question 12. A, B, C, and D are points on the circle with center O. PQ is a tangent to the circle at C. Find these angles. First of all, angle DAC, which is this angle here, DAC. So here we can see that OD, this one, OD is equal to OC, this line, that they are both start from the circumference and they go to the center. So these two are the radiuses, they are equal each other. So ODC here would be equal to the opposite angle, which is 20 here. So this is also 20. then we can see that angle DOC at the center here. So DOC is equal to 180 minus 20 minus 20 equal to 140. So this is 140 degrees. So the angle that we want, DAC, is half the angle at the center. So this will be 70 degrees. This is 140 over 2. As the angle at an arc is half the angle at the center if both start from the same arc. So they both start from DC, the DC arc. One goes to the center and one goes to the circumference. So the one angle at the circumference would be half the angle at the center. So this is our answer, 70 degrees. Part B, find angle ABC. Angle ABC is this one. We can see that the shape ABCD is a cyclic quadrilateral as it touches all the sides of the circle. All the sides touch the circle, the A, B, C, and D. So this is a cyclic quadrilateral. So the opposite angles in a cyclic quadrilateral add up to 180 degrees. So the angle ABC, the one that we want, plus the angle on the opposite side, ADC. So here, this angle, the red one, ABC, plus the angle ADC, all of this one, those add up to 180. So you can write it here. ABC plus angle ADC is equal to 180. And we know that angle ADC is the 40 plus the 20, so 60 degrees. So ABC plus 60 is equal 180. So the angle ABC is equal to 120 degrees. So we can write that here, 120 degrees. We want angle ACQ. So choose a different color. Angle ACQ is this one over here. This is an angle between a tangent and a triangle in a circle. So we know from the circle theorem that this angle, it would be equal to, it's the opposite one over here. So this angle would be equal to this angle. So this angle is also 60, this angle is 40 plus 20, 60 degrees. So this angle would be equal to it, would be also 60 degrees. So this is our answer. Question 13, simplify 5 plus 2 root 3 all squared. So this would be equal to 5 plus 2 root 3 times 5 plus 2 root 3. This is equal to 25 plus 5 times 2 root 3 plus 5, the other one also, 2 root 3, then 2 root 3 times 2 root 3 plus 2 root 3 all square. This is equal to 25 plus, this would be 10 root 3 plus 10 root 3, so 20 square root 3 plus 2 root 3 squared, this would be 4, this would be 3, 4 times 3 would be 12, so it's equal to 37 plus 20 square root 3. So this is our answer, 37 plus 20 root 3. Question 14, find the value of n when log 5 plus log 3 minus log 2 is equal to log n. So all the logs here have the same base. So this is equivalent to log 5, we can log 5, when there is an addition, we multiply, so this is times 3, and there is a minus, we divide by 2, so over 2. So this is equivalent to log 15 over 2, which is 7.5. We were told that this is equal to log n, so n is equal to 7.5. Part B, find log base 3 of 3 to the power of 1 over 4. So here the base and the number, the base of the log and the base of the number 3 are the same. So the answer of this is basically 1.4. Here they cancel each other out and the answer will be left with 1.4. Another way to look at it, we know that y, from the log rules, y is equal log e of x is equivalent to x is equal to b to the power of y. So if we apply it here, we have here that y is equal to log 3 of 3 to the power of 1.4. This is equivalent to the x is the 3 to the power of 1.4. This will be equal to b, which is the base of the log 3 to the power of y. And this is what we want to find, y, which is log 3 to the power of 1.4. So those are 3. The y will be equal to the 1.4. Question 15. F of x is equal to 3 sine 2x degrees. Part A, write down the amplitude of the graph of f of x. So the amplitude is this number here, multiplied by the sine of x, so the amplitude is 3. Part B, the graph of y is equal to f of x goes through the points 75, 1.5 and a 1.5. Find possible values of a that are greater than 75. If we look at the graph of the sine function, this is the graph of the sine, and it keeps repeating itself. The usual sine of x will repeat itself every 360 degrees. So this is 360, this would be 180. But here we have sine 2x. So sine 2x is similar, but it repeats itself every 180 degrees. So it's be something like this. This would be 90 and 180. So a point which is 1.5, we have that the magnitude is 3. So this is here 3, the value on the y. 1.5 would be somewhere in the middle here. And if we just draw a line, we see that here this point at 75 degrees, about this point here, it will repeat itself every 180 degrees. So this point repeats itself here and here and here. The other point with A is also at 1.5. See, it will be one of those points, could be one of those points. So it's A is equal to 75 plus 180 equal to 225. 255. If we add also, so 255, we add 180, it will also repeat itself again. So this could also be an answer for us. So it's 255, can be 435. So A can be 255 or 435. We can also see that there are other values that are equal to 1.5. So it can also be this, the gold ones. This is the difference between this and the one after it is 60 degrees. So the gold one is this one minus 60 degrees. And this one minus 60 degrees. So we can also say it can be 255 minus 60, which is 195, or 435 minus 60, which is 375. So those are all possible answers. You can just say 255 or 435 or 195 or 375.